Welcome back to the YouTube Niagara Learning channel. Right, I've had a message today. Could you please create a video on free cooling strategy for air handling units? Right, to do this, if it's free cooling, that means that we are not using any chillers or a cooling coil. We are just using the return air temperature and the outside air temperature. Now the temperature sensor is really not the way to go. You want a wet bulb sensor really for monitoring the internal temperature that's coming back on the AHU from the area, and you also want that same sensor or another sensor type, exactly the same, a wet bulb sensor for the outside air. Free cooling in AHUs is a smart and sustainable method that optimizes the natural outside air to maintain indoor thermal comfort. It requires precise control and monitoring of the air properties to be effective. You need at least 1 degree differential, i.e. the outside air has got to be 1 degree lower than the return air. So if it's a very, very hot summer's day, you're not going to get a lot of free cooling there. Free cooling can lead to significant energy savings, reduce your operational costs, and enhance the sustainability in the building. First of all, you need to know what an AHU is. Now, naturally, James will know what an AHU is. Some people may not, which is not a problem. For me, an air handling unit is a piece of plant equipment that takes the outside air, and there's different air handling units here, so sometimes they won't take just the outside air, but mainly the majority will take the outside air. It will go through a filter, a panel filter, then normally a bag filter, then it would normally be the fan, and then before the fan you would after the fan you would have a cooling coil, a heating coil, but we don't all have cooling and heating. There's different varieties of this, and then that would then supply the air into the office building or the hospital or whatever. You could have extra filters in there. If it's a clean room, you would have a HEPA filter in there, and the extract air coming out from that room would normally go straight to outside, but you would have the extract air, you would have a filter, then you would kick it straight to the outside. But you can also have, between the extract and the supply, a thermal wheel. They've done many different varieties of actually taking that extracted air and recirculating it back. I think the best thing for me to do is give you some examples here. Let me just put you on pause and let me pull up some examples. Right, we have one example here. So we've got the supply filter here and extract filter there, and we are basically coming in with fresh air here. If you follow the mouse through, we are going through this damper, this fan here, and then we're going through a heating coil, and that would be supplying it out into the building. The extract from the building is this top bit here. We go through a filter again, a panel filter. We've got the motor there, and then it will basically go through this diagonally and it will go out there to the outside. So that is one example of an air handling unit. Fresh air coming in, going through and out. Now we can see that we've got 30.2 degrees return air temperature here on this sensor, and we have got 24 degrees on this sensor here coming in. So that way we could do free cooling, because we could bring the air in through there. That's turned off, which it currently is, and it's sending out a temperature as 33.5. Now that is because this is actually recirculating and mixing with the outside air. So we're bringing in the 30.2, we're bringing in the outside air, and it's mixing. Let's show another one. Let's see if we've got another AHU that we can look at. That's similar to that one, so that's no good to us. That's similar. Right, that is different. That's using a thermal wheel. So this is still our extract through our filter, and this thermal wheel is moving around, and it's got little pockets in there, and those little pockets are moving to there for the air to blow through the outside air to suck through. So it's going through your filter there. So we've got 19.7 outside air, and we're recirculating this, and then we're giving 20.7 at the moment. So it's actually no heating coil on, but we're transferring a little bit of that air, which is coming back at 21, mixing it with the 19.7 and bringing it through back into the building again. I don't know if there's any more examples that I can show you. That's got a heating coil and a cooling coil. Now, I don't know if this heating coil and cooling coil is the right way round. Normally I would see a cooling coil first and then a heating coil, but it must be on this graphic, because if we would have worked to the system air graphics, we've got the ventilation schematic there. In fact, let me just put you on pause a minute. So this is the AHU 5A for the fitness suite, and yes, it's got a heating coil and a cooling coil there. So there's your motor, filter, dampers, and the thermal wheel here. Now, so let's go back to that graphic. So here is the graphic again. Heating coil, cooling coil. So an air handling unit is normally, as I was saying, is a unit that will take air from outside and will supply it into the office areas. And then each office area will have its own fan coil unit, and that will then treat the temperature lower or higher depending on what the user wants in that room. So we want to work on logic for the air handling unit. So let me just put you on pause and go back to the spreadsheet. So this is not connected to anything, but I've basically put the outside air at 0 here, and the external temperature coming back at 10. It's all hypothetical, but I'm trying to show you about the free cooling. So if we follow this through, this is my free cooling folder here in this logic. So external temp is 10, outside air is 0, so it's really cold outside. So free cooling is available. So outside air is 0, external is 10. So we're basically got a differential there. It's a free cooling T-stat there that we've used. You can see the differential there is 1. Maybe that should be 2, 1 degree either side, but we've left it at 1 here. And that free cooling is actually on at this moment in time, because it will be. Outside air is lower than the inside air. And if we follow this through from the free cooling, it will go into this supply temperature here folder, and there's my in switch there, which is true. So if it's true, it's using this. And we've got in here as another folder. There's my output of that folder, and we're subtracting here different calculations. So minimum set point -5, maximum set point -20. And if we follow it through, probably not making a good example here. It'd probably be better to see it in live working calculation. That's my loop heating and that's my loop cooling. Let me, which is in coming out in B there, which is 0 at the moment, but if that was 100%, that would then be 100. In fact, let's try and make that 100%, just to try and give you some sort of idea. So let's just take the minimum and put it to 100. So it's always at 100. Thing is, I'm not on I'm actually just running on logic here. I'm not actually running this software, so that's not going to really help much by me doing that. I really need to show you on a live system. Let me show you on a live system. One moment. Right, so it's exactly the same software, but we're on a live system now. And if we go back into the free cooling, we've got outside air at 25.92 and external at 23.3. So we do have a difference between it, and that is actually true. So we will follow that through into this free cooling here. True. So there's our switch. We're in true. So it would take it from there. Now our out at the moment is 0, because we are actually using the heating loop at this moment in time to maintain the temperature. But if we wasn't using the heating loop and we was using the cooling, then that would be different. But unfortunately, I can't mess with this. This is a gallery air handling unit, so I certainly don't want to be playing around with this. In fact, I'll show you this as an AHU as well, and then maybe we can write some software later to show you how it all works. If I go to my PX here and go to my gallery AHU, this is another air handling unit, and we've got a thermal wheel here, as you can see, and we are extracting 23.3 degrees temperature through that panel filter, through the motor, the fan motor. We're not recirculating anything at all. That's at 0, so that is now closed. But we're recirculating, no, sorry, that's at 0, even though it's spinning, it's at 0, so we're not recirculating that. So that air is being took straight to the outside. So 23.3 degrees air is going straight to the outside. We're taking air in from the outside, going through a panel filter, going through a bag filter, we're going through another filter as well. Bear in mind it's a gallery, so we've got to make sure we are putting clean air into this. We've got the temperature there at 23.4. We're not recirculating because that's roughly the same temperature there. We're going through that motor there, pushing it through the frost coil, which is fine. There's no cooling coil on. There is a heating coil, and we are giving 24.3 degrees at this moment into the gallery. CO2 level is 866 or 808 parts per million, so that's fine. Humidity is at 41, temperature is at 23.2 for the gallery space. So everything looks fine there. I can't see any issues with that whatsoever. So we're just taking the air straight out to the outside, pulling in fresh air from the outside, and we're treating that with this heating coil at the moment. The calculated set point it's wanting is 26.51 degrees. And we're at the moment giving it 24.3, hence that's why we are heating, and we have it to 100% at this moment in time to try and maintain 26.51 calculated temperature. Let's just do some simple logic just for the free cooling business, because that's what the question was anyway, but it's giving you some ideas of some AHUs, and the logic can be complex. It's not as simple as what you think it may be, depending on what you need to do. I mean, if we look at the engineering page here, we've got the pressure there, supply and extract pressure, so it can be adjusted. The fan speeds can be adjusted. The gallery space temperature there, the temperature set points, which from them temperature set points is what the calculated supply temperature is coming to. You got your mixing air temperatures there, your air quality, etc, etc. So let me close this one down and let's just open up a spreadsheet. I'll put you on pause again. So let's give you an example here of this free cooling. We need to make a folder. My computer's just gone on a go slow. Let's just make a new folder in here. Folder free cooling. And let's just go into that folder. So the first thing that we need, one moment. Right, numeric writable. OAT, outside air temperature. Duplicate that. And we've got extract air. So at the moment we've set outside air. We'll set that to, I don't know, 23 degrees. And we'll set the extract air at 26 coming back from the building. Nice and hot. So we need a 1 degree differential at least. So we can use a T-stat for that. I want to go into kit control, and I want HVAC, and I want a T-stat. And pin slots, diff set point. We'll open up the action as well, and we'll just put that one into there, put that one into there, and differential, we'll put that at a 2, 1 degree either way, and we will reverse that for the moment. So that's at 23, that's at 26. If I drop that down, actions, set that to 21, we've got a false there. So we've got the extract air lower than the outside air, so we can't do any cooling. Actions, set that to 23, and we shouldn't be able to do any cooling still. It's gone to a null there, so let's just put that to true. False, sorry. And that, false. and then we'll go to set that to 24, and we've got a true, because the extract air is 1 degree higher than that. So if we change, say we didn't go for 1 degree and we went for 2 degrees either side, and we'll drop that down to, set that down to 20, false, actions set to 24, it's still false. Last time it was true. Set that to 25. It's now true. So we've now got a 2 degree, and we can make a set point for that of what differential we want, so the client can adjust it. So OAT underscore extract, done that in capitals there, extract differential, and actions set, we want 2 degrees differential. Let's set that to 2 degrees on here. So up at the top there, let's go down to our temperature, put it to C for degrees. We'll take out the position. No, we'll leave the position in, and let's say we can do a minimum of 0 and we can't go any more than 10. No, that's going to be a lot. Can't go any more than 4. And I also want to take out those pin slots, and I just want to put a set there, and then I want to view, because at the moment when you view this, if I go actions, I've got all these, I only want this set one to be used. I don't want them to see any of these at all. So views, AX slot sheet, highlight emergency override, press my shift key, highlight auto, right click, config flags, hide them. So now all they can see, actions, is just a set. Now 2 degrees is actually going to be 4 on the differential, so we want to multiply that 2 degrees. So we'll open up our maths and we go to multiply, and we'll put that into there, and we ask it to multiply it via 2, which will give us a 4, and we can put that 4 into our diff. So when we select a diff of 1 either side, that's going to be a 2. So just to show you again, actions, set the extract air to 20 degrees, there is no diff. Actions, set to 24, it will come on this time. There you got your true there. Where when we was at a diff of 2 either side, if I put that now down to action set to 20 and then put that to 24, it won't come on. False. Action set, if I do 24.9, still not on. Actions set 25 on. So that's us taking the outside air temperature and making sure that it's lower than the extract air temperature of whatever we set there, in this case 2 degrees. And that gives us our output ready to do the cooling. That is your free cooling. That is your free cooling. Writable not numeric writable, I want a label. New text block, note, free cooling. And we'll put a background of blue on there. And we'll give it a border. And we'll do bold. Save. That is actually our free cooling block. Rename. CLG for short. Free cooling. What can you do with that true? Well, you can increase the supply fan from its normal speed and add a little bit more to it to increase that. When it's true, you want to make sure that your bypass, if there is a bypass on the AHU, is actually closed. So you're extracting all that air outside and you're not recirculating. So that true would be going into an AND gate to make sure, I mean, you could put a NOT gate there to reverse it. So as it's true, and when you recirc, let me just show you what I mean. Logic NOT. So if you've got your logic that is recircing at the moment, so say we've got recirc on, new boolean round, so recirc on, so we're recircing on at the moment, action set to true. So in the logic somewhere the recirc is on, and new, and the boolean writable output enable recirc. If it's just an on and an off, actions set that to true, enable. In fact, let's just change the text there and just put it to enable and disable. Or it may be that you're using a 0 to 100% on a valve. So let's just go new, numeric writable, damper recirc. And it could be that that damper is set to 100%. And then you've got some logic here that's telling it 100%. So numeric writable and recirc on 100%. Action set 100%. So you've got some logic, other logic that's saying that we want the recirc on, and that's going to go to there, or it's just an on and an off, and that's going to go to there. And then this here we want to break into this. So if it's on this output here, how I would break into that is I would take that false, so I would put an AND gate in here, and put that there, take that out of there, put that into there, and rename free cooling enable. And I would take that into there, so I would disable the recirc. That's how I would disable the recirc. If it's this particular one, we would use a switch in utilities and numeric switch and free cooling again, enable. Notice I've done an underscore there because you can't have two blocks with the same name. And our switch, we can take that, still take that false there. So when it's false, we are using that as true, and that is going to go into there. And so while it's false, we're putting that to 0. So let's now lower this extract air temperature. So let's set that extract air temperature to say something like 20 degrees, so it's cold in there. And as you can see, the recirc now is enabled, or if you're using a 0 to 100%, the damper recirc has actually increased, because now we're in a situation where the outside air is actually higher than the extract air coming from the building. So we don't want to do, well, we can't do free cooling now, it's impossible. So we're in a situation now where the recirc's back, and it's recircing the heat basically back to the room, and mixing of course with outside air. We can go on and on with this, but for the simple logic, that is your free cooling. I wouldn't use temperature sensors, I would use wet bulbs, because that will give you a lot more precise for the free cooling, because that will monitor, that will look at the moisture that's in the air as well, the humidity. So I would use that rather than temperatures, but you can use temperatures. I wouldn't use a 1 degree either way. I would use a minimum of 2, definitely. And in case you wanted to check that, or make sure that they can't use anything less than that, you would set that minimum there to 2. And then that way they can't go lower than 2. So if you try and set that lower than 2 and set it to a 1, it won't let you. It's giving you the 2 to 4 setting there. So you can try and put it to a 1, but it's not going to let you do that. It's got to stay at a 2. But I could put it to a 3, or I could put it to a 4. Well, I think 2 degrees using normal temperature sensors would be enough for your free cooling on your air handling unit. Naturally, there's a lot more logic involved in the air handling unit, but it's as simple as that for allowing free cooling, because you can't get it from the chiller, because that's not free. That's costing you to make that water, that cold water. You can only get it from outside air. That's the only way to do free cooling, is actually from the outside air. And the outside air has got to be, I would say, 1 degree will do it, but I would say a minimum of 2 degrees differential between your extract air and your outside air would be suitable. And naturally, we're not in free cooling mode at the moment now, purely because of the extract air being 20. But if I put that above, or let's move the outside air, do it the opposite way. If we set the outside air to something like 15 degrees outside, then of course you've got your free cooling. I think that explains it. By all means, put a comment in the box below, in the comments box, and we can go on further. But the AHUs, there's a lot of logic, as you can see just by looking at this gallery logic that I was showing you right at the beginning. It's not just down to free cooling. There's a lot. The external fan control on pressures, supply fan control on pressures, dampers, alarming if your damper doesn't open. That was the free cooling folder that we just did. There's so much. You've got your emergency stops. But there's a lot more to it, and of course all your set points. D-hum set point there, RH set points. The higher the RH, the more we want to basically get rid of that moisture in the air and bring in, or if the air's too dry, we need to do a humidity. Again, there's a minimum fresh air folder there, cascade set points, supply temperature, humidity control is there, mixing dampers. There's so much to an air handling unit. But I've answered your question for free cooling. That's how we would do the free cooling. But there's a lot more involved in logic for air handling units. I hope that's answered your question. Yeah, let's see what the comments are below, and then we can move forward with further air handling unit comments if you need. Thank you for watching.